So you want to do something like find the line parallel to 2x minus 8y plus 11 equals 0 that passes through the point 3 minus 1. So this has got a few different things to do, and we're always falling back on the general equation of a straight line. Y equals mx plus c. The first thing to notice is that this is not in that form, so we can't readily see what the gradient of the line is, and we do need that. So can we put that into this form? Well, yes we can. I can see we've got a minus 8y here, and then if we move everything to the other side, so if we take away 2x from both sides, if we take away 11 from both sides, we'll end up with minus 8y equals minus 2x minus 11. And then if we divide right through here by minus 8, then we'll leave y on its own, as long as we divide on the right hand side by minus 8. And then we can tidy that up and simplify. We've got minus 2 over minus 8, minus over a minus is positive, and then 2 over 8 just simplifies to 1 quarter, so 1 quarter x. And then here we've got a minus over a minus. A minus over a minus is going to give us a positive 11 over 8. And we can kind of leave it like that. Now the thing to notice here is that we're looking for a line that is parallel to this line. Parallel to this line because we've just rewritten it. If we're looking for a line that's parallel to these lines, or this line, then it will have the same gradient, 1 quarter. So when we go into the next section here, if we write again our general equation of the straight line and then just decide what information we have, well, we know that y equals, on the line we're looking for, which is parallel, it must have the same gradient. So quarter x plus c. So then we can think about, well, what else do we know, or what else can we find out? Well, we can find out c, and the reason we can find out c, and that's the y-intercept, is because we know a point that this other line that's parallel, we know a point that it has to go through. We're told in the question, passes through the point 3 minus 1. So what we're being given is an x coordinate and a y coordinate. We know that when this line goes through x equals 3, it's at y equals minus 1. We're told that. And so we can substitute that information in here if we want to find the y-intercept, where the line goes through the y-axis. So let's sub that in. We have y equals minus 1 when x equals 3. So we've got minus 1 equals 3 quarters, because I've just multiplied a quarter by 3, plus c. And therefore minus 1 minus 3 quarters equals c. Because if I take away 3 quarters on both sides here, then I'll end up with this. So minus 1 minus 3 quarters is minus 1 3 quarters, and minus 1 3 quarters we might write as minus 7 over 4. So we've now found the y-intercept of the line parallel that goes through the point 3 minus 1. So again, if I write my y equals mx plus c and just keep falling back on writing that and then thinking about the information we can put in. I've got y because that's a variable here. I know that the gradient of my new line, the one that's parallel, must be a quarter. We'll leave the variable again because y and x will change right as we go along the graph. And then plus the y-intercept that I've found, which is of course minus 7 over 4. So I just say minus 7 over 4. So this is the equation of the line that is parallel to this line, which we rewrote as this. Of course, it has the same gradient, and we were able to find out the y-intercept by inputting the coordinate that we know this parallel line goes through. So that was the process there. And then we've rewritten, going back to our variables y and x, because y and x of course change as the line goes along the graph. But the gradient doesn't change, that's constant on a straight line, and the y-intercept will never change either, that will be a constant. Now we could rewrite what we've got here in a different form. We've got these 4's on the bottom, so if we multiply right through by 4, we get 4y equals x minus 7. And we could rewrite still further by saying that, well, 4y minus x plus 7 equals 0. You might see it written in that form as well. So there we go.